To figure out what the graph of an exponential function with base e looks like, we're going to start the same way we did before, which is by plugging in numbers and plotting points. So when x is equal to -1, e to the -1, we can plug into our calculator to find a decimal approximation for that. We'll hit second, ln, and then put the -1 in the exponent, and that tells us that e to the -1 is approximately 0.4. When x is equal to 0, anything to the 0 is 1, including e to the 0. And then when x is equal to 1, e to the first power is just e, which we said is approximately 2.7. So then plotting these points, -1, 0.4, 0, 1, and 1, 2.7. And then connecting those, and we see the graph of e to the x looks very similar to our other exponential functions where we have a base greater than 1. So now if we want to graph an exponential function with base e with some transformations to it, we're going to start with this basic set of points. So when x is -1, e to the x is 0.4. When x is 0, e to the x is 1. And when x is 1, e to the x is 2.7. And then we plot those points. And now start going through the different transformations. So the negative in front of the e tells us to flip our graph over the y-axis. So that's going to flip this point down to a -0.4, this one to a -1, and this one to a -2.7, giving us something that looks like this. And then the +2, since it's on the inside with the x, that tells us to move to the left 2. And then the -3, since it's on the end outside of the exponent, that tells us to move down 3. So I'm going to take each of these last set of points and move them left 2, down 3. So this one is going to go left 2, down 1, 2, 3, so that it ends up at -3, -3.4. This point is going to go left 2, down 1, 2, 3, putting it at -2, -4. And this one is going to go left 2, down 1, 2, 3, so that it ends up at -1, -5.7. And then we connect those to end up with a final graph of g of x that looks like that.